Welcome students. Today's video is on solving systems of equations by elimination. We're going to start with the simple case of addition and subtraction. These are the steps for using the elimination method. You have these on your note sheet. I suggest that you check these off as you're doing them as we do the problems together. Solve the system by using elimination. Elimination is essentially using addition or subtraction to make something get eliminated. As I look to solve this one, I set it up as either addition or subtraction. If I see that I have opposite signs and a matching coefficient or matching front number, then I'm going to add. If I have the same sign, that's when I'll have to subtract. So always remember, add the opposites. This, I see 4 and 4 at my x's, so I know I'm going to add. Negative 4 and 4 will add to give me 0x, so that gets eliminated. 3y plus negative 5y gives me negative 2y. And negative 3 plus 5 gives me 2. If I divide both sides by negative 2, I know y is equal to negative 1. Now that I know y, I just have to plug it back into one of my original equations. So negative 4x plus 3 times y, which is negative 1, is equal to negative 3. Negative 4x minus 3 equals negative 3. I'll add 3 to both sides. I get negative 4x equals 0, so x equals 0. That gives me the ordered pair 0, negative 1. Again, we're going to look and see if we can find some matching coefficients. If I match up my x's, I see I have 4 and negative 4, or if I match up my y's, I see I have positive 3 and positive 3. So it really doesn't matter if I choose to add or subtract here. I'll just choose to add. So 4x plus negative 4x will cancel. 3y plus 3y will become 6y, and 22 plus 14 will become 36. If I divide both sides by 6, y is equal to 6. Now I can take y and plug it back into the original equation. So 4x plus 3 times 6 equals 22. 4x plus 18 equals 22. I would solve this by subtracting 18 from both sides. That gives me 4x equals 4. I can divide by 4 on both sides and get x equals 1. So I finish with the ordered pair 1, 6. Again, we're going to solve using elimination. If I look at my y's, they don't match up, but my x's do. I have positive and negative, which means I need to add to eliminate. Those will cancel. Y plus 3y is 4y, and 13 plus negative 1 is 12. If I solve this, I have to divide both sides by 4, and I get y is equal to 3. Now that I know what y is, I can plug it back into the original, so 2x plus 3 equals 13. I can solve this, so subtract 3 from both sides, that gives me 2x equals 10, and now I know x is 5. So I get an ordered pair 5, 3. Notice this technique is much faster than the substitution we were doing yesterday. Try this next one on your own. First, you need to decide if you are adding or subtracting. Pause the video and unpause when you're ready to check. You needed to subtract in order to eliminate. The x's would cancel. 3 minus 7 would give you negative 4y. 11 minus 15 is negative 4. And we could have divided by negative 4 to get y equals 1. Then I wanted to plug that back into either of the two original equations, and I would have eventually figured out x was 1. So I end up with an ordered pair of 1, 1. Looking at this next equation, I can see that my x's don't match but my y's do. They have the exact same sign, which means I need to subtract. So 3x minus 5x is negative 2x. 2y minus 2y becomes 0. And 12 minus 16 is negative 4. If I solve for x, I'll divide by negative 2 on both sides. That gives me x is equal to positive 2. Next, I want to plug that back in. So I will rewrite the original equation, replacing my x with 2. So 3 times 2 plus 2y equals 12. 6 plus 2y equals 12. If I subtract 6, 2y is equal to 6, so y is equal to 3. And I have an ordered pair of 2, 3. Try this next one on your own. Again, you need to decide, will you need to add or subtract? We add the opposites, we subtract the same. Pause when you're ready to check. You would have chosen to subtract. You remember that 5 minus negative 2, we add the opposite and we get 7x. We eventually solve and get x equals negative 3, which we then plugged back into the original equation and solved for y equals 1. Looking at this next equation, I see that my y's match. That means I need to use subtraction to cancel. 1 minus 2 will give me negative x. My y's will cancel. And 16 minus 18 will give me negative 2. I can flip both signs and figure out x is equal to 2. Then I just have to plug it back into one of my original equations. So 2 minus 4y equals 16. If I subtract 2, I'll get negative 4y equals 14. Divide by negative 4. 14 divided by 4. 4 will go into 10 twice with a remainder of 2, and it'll go into 4 one more times. So we end up getting 3 and 2/4, or 3.5. So my ordered pair for this one is 2, 3.5. Try this next one on your own. Unpause the video when you're ready to check. If you solved correctly, you would have added. That led you to x equals 3, which you could then plug back in to find out that y was equal to 0. Try this next one on your own. Unpause when you're ready to check. You would have added the two together. That led you to 5y equals 15. We divided both sides by 5 and got y equals 3. Then we wanted to sub it back into the original, where we got x equals 1, which gives us an ordered pair 1, 3. On this next one, pay very close attention to how things are stacked. So sometimes we'll make a mistake just by simply not looking. If I look at this column, I see y over x and x over y. I want to rewrite these so that they're stacked over each other the way they should be. So the top equation, negative 3x plus 2y equals 12. And the bottom equation, 6x minus 2y equals negative 12. If I go to solve these two, I can see right here that my y's are opposites. If I want them to cancel, I'll add. That will eliminate my y's. That gives me 3x. 12 plus negative 12 will give me 0. I can divide both sides by 3 and get x equals 0. Now I can plug x back into either of the original two equations. So 2y minus 3 times 0 equals 12. 2y minus 0 equals 12, which means 2y is equal to 12. Divide by 2, and y is 6. This gives me the ordered pair 0, 6. Thanks for watching.